Hi viewers, in today's video we are going to see how to find the trigonometric ratios of 30 degrees, 45 degrees and 60 degrees. So in case this is your first time of hearing trigonometry and you are trying to confuse yourself, I'm going to make a video on trigonometry even before doing this part. The reason I'm doing this video before treating trigonometry is I want to show you how sort that we've discussed in our last videos is being applied in finding the trigonometric ratios of 30, 45, and 60. So let me just give you an insight of what trigonometric ratios are. So there's what we call, this is just so we have three different trigonometric terms we'll be using. This is sine, cosine, and tangent, right? These are the three things we'll be talking about. So when we say sine, you can see, look at this. This is just, I want to make you understand how it's done, right? So when we say sine, you see this is letter S, right? Sine is, you see, O over H, right? This word O, this O, let me just give you the meaning. O means opposite. O means what? Opposite. H means hypotenuse. H means what? Hypotenuse. Yeah. C means cosine. S is sine. C is cosine. This A here means adjacent. A means adjacent. O means opposite. So I don't think we have anything to discuss. O is always opposite. A is always adjacent. Then H is always hypotenuse. So for sine now, recall that sine is always opposite over hypotenuse based on what is here, right? Immediately you just hear me say sine, it means opposite over hypotenuse. So how about when we say cosine? Cosine is adjacent over hypotenuse. When we say tangent, tangent means opposite over adjacent, which is O over A. So these are three things to be focused on so very well to get the 30 degrees, 45 degrees, and 60 degrees. So even before doing this, I'm supposing and thinking that you have an idea about uh, triangles and polygons, angles in a triangle and the likes, right? So for this one, for 30 degrees, look at what I'm going to do. Suppose I have a triangle. Let me just draw that here. Let's have a triangle, an equilateral triangle. Let's draw it this way. This is an equilateral triangle, right? So I'm trying to assume all the sides are equal, right? So that means I can just cut this down, right? So with this now, look at this. When all the sides are 2, 2, 2, 2, it's equilateral triangle. That means all the sides are what? Are equal, right? So how do you calculate the height? For instance, if you want to calculate the area of this equilateral triangle, how do you calculate the height? It's just to use our Pythagoras theorem, which I've been telling you guys how to find the missing side of a triangle with the Pythagoras theorem. To do that, we all know that, let's assume this is a right angle triangle, right? Of side A, B, then C. To find C, let me make it this way. C square is always equals A square plus what? B square, right? I've been saying that. And our A square is always equals C square minus what? B square, right? How about B square? B square is equals C squared minus A squared. These are the formulas for the Pythagoras theorem, right? So to calculate the height, you can see that the longest side of the triangle, that's if you cut it into half, the longest side is 2, right? We call the longest side our hypotenuse. Let me draw this and label it here. You know we have 90 degree here, right? So we have an angle here, let's say theta. So if this is the angle, the longest side here is what? Let's call it, this is our hypotenuse because it's the longest side, right? Our hypotenuse. The side that is opposite the angle, we call it opposite, right? This is our opposite. So the side that is close to the triangle, but it is not the, you can see that the longest side is close to the angle as well, right? But you won't consider that. You pick the side that is close to the angle, but it is not the longest. So this is our adjacent. This is adjacent, right? So how do we calculate for adjacent? Normally, adjacent is just like our, is it b square? Yeah, so b square is c square minus a square, right? So let me just not suffer and let me not stress you guys by deriving all of these step by step. The answer to this very part is going to be square root of 3, right? I shouldn't have even spoke about the Pythagoras theorem for now. Sorry for that. Let's just go straight. I will talk about it in coming videos. So if you solve this, you're going to have this height to be square root of 3, right? So since we have square root of 3 here, what is our, you can see that this side I have 90 degrees. I have 90 degrees, right? And angle in the triangle is 180. So let's call this place to be our 60 degrees. Then this place to be our 30 degrees. You can see that 60 plus 30 is 90. 90 plus 90 is what? 180. So 17 is here. This is 60 degrees. This is 30 degrees as well, right? So look at this. I'm trying to just, I'll be looking at this in a different, I can just remove this part and it's 17, right? What I mean is I'll just make it like this. Our hypotenuse we said is 2, right? But look at, I've cut it into half. That means this place is 1, right? Because 1 plus 1, I've divided 1 plus 1 will give me the whole thing, right? So this place is 1. Then this side is going to be square root of 3 because that's the side that is missing, right? So, and we have our angle here, theta, which is 60 degrees here. And up here is what? 30 degrees. So now look at, if they say sine, let's come here. Is it, we'll be talking about 30 and 60 here, not 40. 40 is not included here. So what is sine? What is sine 60 degrees? Sorry, let's start from 30. Sine 30 degrees equals what? What is 30 degrees? What is sine? Sine is opposite over hypotenuse, right? So look at this. We have 1, which is our what? What is the opposite? Opposite of, when you're talking about 30 degrees, look at where 30 degrees is. That means the adjacent is this part and the opposite is what? 1. So it's going to be 1 over, what is the hypotenuse? 2. So sine of 30 degrees is going to be 1 over 2. How about cos of 30 degrees? Cos 30 degrees is going to be, cos is what? Adjacent over hypotenuse. What is the adjacent of when it's 30 degrees? That's square root of 3 over what? Hypotenuse, which is 2. So it's going to be square root of 3 over 2, right? So what is our tan 30 degrees? What I mean by tan 30 degrees, tangent of 30 degrees. So what is that going to be? Tan 30 is just something, opposite over adjacent. What is the opposite when it's 30 degrees? Opposite of this 30 is 1, right? So 1 over, what is the adjacent? Adjacent of 30 degrees is square root of 3, which you can rewrite as how? Remember what I said when we were doing the videos on sort? I said when you have something like 1 over square root of 2, you can just multiply by square root of 2 over square root of 2, which is going to be square root of 2 over what? 2, right? So this one, I can just write it and say the answer is going to be square root of 3 over 3. So we are done with 30 degrees now, right? So how do we get that of 45 degrees? Oh, sorry, 60 degrees now, because you can see I don't have 45 degrees here, right? So for 60 degrees, our sine 60 degree, just same formula. We'll just, the thing is we'll be using 60 that is down right, here right now. So sine 60 is going to be opposite over hypotenuse. What is the opposite of 60? You can see the opposite of 60 is what? Square root of 3, right? So square root of 3 over, we said it's hypotenuse. What's the hypotenuse when it's 60? It's still going to be 2, which is square root of 3 over 2. That means cos 30 and sine 60 are the same thing. You can just try that on your calculator and check if it's true. Cos 30 and sine 60 to be same thing. So after sine 60, let's check cos 60 degrees. What is cos? Cos is just adjacent over hypotenuse, right? So what is our adjacent when it's 60 degrees? That's 1, right? 1 over, what is the hypotenuse? 2, right? That means 1 over 2. So is it true that sine 30 is equals to cos 60? You can see that something is really happening here. So how about tan? tan 60 degrees is going to be what? So let's do it something opposite of our adjacent, right? So what is our opposite? Opposite is square root of 3, right? So square root of 3, okay, yeah, square root of 3 over what is the adjacent? Adjacent is 1. So we have 1, which is equals to square root of 3. You can just see even let's not talk about that for now. So we are done with sine 30, sine 60, and the rest. Let's talk about 45 right now. 45 is not going to be derived from this diagram. We have to form the triangle that has 45 degrees. So we are going to have something like this, right? So I'll call this square root of 2. I'll call this side 1, 1. So we will call this side is 90 degrees. This side is 45 degrees. This side is 45 degrees. So this is what we'll be using to derive the formulas for our sine 45, cos 45, and tan 45. So what is, let me split this down. Talking about this, what is our sine 45 degrees? Sine 45 degrees is going to be, what is sine? Sine is opposite over hypotenuse, right? So what is our opposite? Opposite with respect to any of this is just something. The opposite is 1, right? Which is 1 over, what is the hypotenuse, right? The hypotenuse here is going to be square root of 2. Square root of 2. But if I leave it like that, you know, this answer is still in the is still a sort, right? So how do we make it a rational number? By multiplying the top and the numerator and denominator by square root of 2. Square root of 2, this is going to be square root of 2 over 2, because 1 times square root of 2, square root of 2, square root of 2 times square root of 2 is what? 2. So how about cos 45 degrees? Cos 45 degree, what is cos? Cos is just adjacent over hypotenuse. What is our adjacent? Our adjacent here, the adjacent is 1, then over hypotenuse. Hypotenuse is what? Square root of 2 again, right? So adjacent 1, hypotenuse square root of 2. So 1 over square root of 2, which is what we said here, which is square root of 2 over 2. So that means sine 45 and cos 45 are what? Are same thing. How about tan 45? Tan 45 degrees is equals, what is our tan? Opposite over adjacent. What is opposite? Opposite 45 is 1, right? The opposite of 45 is 1, because if you consider this one is 1, you consider that one is also 1. So I'm going to have 1 over, what is the adjacent? The adjacent is still 1, which is 1 over 1, which is equals to what? 1. So that means the tan of 45 degrees is equals 1. Cos of 45 is square root of 2 over 2. Sine of 45 square root of 2 over 2. And just, you can see that's how you can just derive your trigonometric ratios of 30, 45, and 60 degrees. So the reason I made this very video is you can go for some mathematics competitions like Olympiad and the rest, that calculators are not allowed, right? So when you go for such competitions, if calculator is not allowed and you are given a question, especially in bearing and distance, you can just be given a question that has angles in them, and you can just imagine you don't have your scientific calculator. How do you do that? You just have to get the concept of deriving your formulas from the table from this very diagram of a triangle I drew here. You can just use this and get the answers. So in case you are trying to also talk about that of 90 degrees, let's say sine 90 degrees now. You know, I've not done that of 90 degrees here, right? So the only thing you'll be doing is, let me just say it in this video, just watch out in our next video on how I'll show you how to get the angles of different angles of triangles. So we call these angles the spatial angles. So don't miss the next video to come, because I'll be discussing so very well on this. I'll talk also about the beginning of the trigonometry and all of these things. So thanks for watching. I hope you enjoyed the video, and if you really do, then I think you love to share this very video, subscribe, and drop a comment on corrections, observation, and anything you observe about the video. Thanks for watching.